So this next part is what we're really excited to be sharing today. So if you're here today, you are all invited to help us with this project that we're working on. And you will actually be able to contribute to what we're calling a permissionless snaps directory. And I'm going to start out by explaining why this is important, okay? So the ultimate question that we're trying to solve at MetaMask is how can users determine whether software is safe to use, okay? So for example, you have all these little softwares here. They're all super cute. They're these little robots. But how do you know which ones are safe, right? Maybe one of them is malware. It looks cute, but you really don't want to install that on your computer, right? How would you know? To give you an example of this, if you think of distributed software systems, how many of you use NPM? You all do, trust me. So NPM is great, right? It's a public registry. Anyone can put packages on there, right? It has a very simple interface that you conform to. And the idea with NPM is it's up to you which packages you want to use, right? There's nothing that the NPM package system or directory does to try to warn you or protect you from malicious packages, right? It's up to you. And so, believe it or not, oftentimes malware will make it onto NPM. And so there's actually projects like these. This is a Twitter account or X account called npm malware, npm_malware. This is a really fun account to follow because you will see all of these reports over time of just all the malware that's appearing on NPM. Sometimes it's a package that gets introduced that's malicious. Sometimes the package was fine, and then an update was made, and the update is malicious. Sometimes it's by mistake, sometimes it's intentional, but you don't know as a user. And if you've worked with NPM packages, you've probably heard people say, pin your packages, right? You have to pin your packages to specific versions. And the reason for that is, if you just blindly update your NPM packages, you don't know if you've suddenly introduced a vulnerability into a package because you don't know that, how the code has changed. There's nothing that the system does to protect you from that. So what do we do about that? Well, the old approach to preventing this sort of thing is centralized reviews. And this is an image of a gate because we often call this gatekeeping. Gatekeeping is not necessarily bad. It is the way by which you try to prevent malicious software from getting to users, right? So software systems like iOS App Store, Microsoft App Store, Windows App Store, whatever, they have reviewers who intentionally review these applications to try to see if something is malicious or not, right? And they're trying to protect their users. But unfortunately, stuff gets through. Okay, every now and then something will get through. So people think that Apple's App Store review process is super solid and nothing gets through, and that's not true. And one example of that is recently Apple approved a fake app that looked like a real app. So they were reviewing Rabby Wallet, and while they were reviewing Rabby Wallet and it wasn't on the App Store, they approved another wallet that pretended to be Rabby Wallet, but it was malware, and people lost money, right? So some people actually got phished by this fake app that Apple accidentally approved, okay? And that's not an isolated incident. This happens pretty often, right? That something will get through and users will end up getting phished or, maybe hacked by this malicious software. Similarly, the Windows Store has had instances of malware getting through. And this one instance, which is called ElectronBot, is really interesting because this malware was put into a bunch of apps that just imitated other apps. And it was put onto the App Store and it got through, like the reviewers never caught it. And then it was just there for a long time. And so there were just a bunch of apps that had this malware in them and nobody realized it until someone this cyber intelligence firm figured out that there was all this malware in a bunch of Windows Store apps, right? So just because something is reviewed or vetted by a central team doesn't mean that it's safe. There are plenty of instances where things get through. And what we're talking about here is not a new problem. This is an ongoing problem, okay? So we're talking about the history of computing and distributing software. So when we look at the history of software, 1950 was, mainframe operating system that didn't have applications. Everything was built in, right? You didn't really distribute applications. But 1971 with Unix, you had packages, right? MS-DOS, you had a bulletin board system where people would get applications. Windows, we've talked about. Linux also uses package managers. Mac has the Mac App Store. Extensions, you have your Firefox add-ons, your Chrome Web Store, etc. Mobile apps. This is all what we call permissioned distribution. You have to go through a review process, and they hope that they can catch anything that gets through. And with what we're doing, if you think of the MetaMask Snaps platform as another execution environment, which it is, but if you think about it that way, we have an opportunity to do something different. So what we're doing right now is still a permissioned approach, right? We have an allow list. We have to review everything that comes in. But we do not want to do that forever. So we have an opportunity to try something new, and you have an opportunity to try that with us. So we're going from permissioned to permissionless, right? So permissioned, based on centralized curation, it's a bottleneck, right? One team cannot possibly catch everything. In a permissionless distribution system, you have community insights. You have a community that's working together to vet and verify everything that's coming through the system and can make informed decisions, can gain reputation, and can help each other identify what is safe to use and what is potentially risky. And so in this new approach, snaps are actually vetted by community sentiment. So you may have a specific version of a snap. Let's say it's Bitcoin Wallet version 1.0.2. It can be endorsed by users. It can be in review as it's undergoing a community sentiment. Maybe there's a debate. Maybe some people endorse it. Some people dispute that. It can be flagged by the community as potentially dangerous. And then users can get this information from the community and have a better insight into what is safe to use. And all of you, like I said, are invited to test this with us. So what I'm showing you is not just an idea that we're working on. I'm going to actually show you what we've built in collaboration with Karma 3 Labs. And yeah, you're going to be able to start playing around with this after today. So we have a version of our directory that we just launched. And the directory is at snaps.metamask.io. And the version that you're going to test is at permissionless.snaps.metamask.io. It looks pretty similar, but one difference is that you can actually connect your wallet and connect an account. And the reason you can connect an account is you can actually use this account to interact and to vet snaps. So here we go. I'm connected with my, this account. And so you can actually go to each snap, and you can endorse snaps. And you can say, OK, this is the Starknet snap. I apologize. It's a bit small for those of you in the back, but I'll read it out. Endorse Starknet. I can endorse it on different topics. Good user experience, useful, seems secure. OK, so I think this one is all three. I'm going to click all three. Sign to endorse. I sign with my Ethereum account. OK, and now I've endorsed the snap. This snap has 23 endorsements and 4 reports by the community. And because it has so many endorsements, it's considered to be endorsed by the community. I can also look at users. So I can see all the users that are in the system, and I can endorse users for different things, right? So this is my colleague over here. I can endorse him. I think he's proficient both in software development and software security. So I'm going to sign here and endorse him for those things and say, yep, I'm endorsing him. I can also go back and say, OK, maybe I need to dispute something. I apologize to whichever snap is about to suffer this example. So maybe I want to report a snap. So I can report this snap as malicious, and I can either say it's scam or it has some vulnerability, and I can sign to report that, and it will actually show up as a report. The other thing that's really cool about this is that this is using an on-chain system that's building a profile. And so I can actually see this explorer of all of the different attestations that are being made. Now, I apologize. This doesn't look super clear on here. Let me just refresh this. OK, so I can actually see snaps that have been endorsed. This is a graph of different snaps that have been endorsed. And then I can do, let's see. I think I made a mistake here. I can see snaps that have been reported, right? So these are snaps. I can hover over a snap and see information about it. These are different users. Here's Simon Brown. Then this blue box is a snap. So this is an example snap, and this has been reported by users. Likewise, if I look at a snap that's been endorsed, here's Filecoin Wallet and has been endorsed. And so I can see all these different connections of endorsements and disputes made between users as nodes and snaps as nodes. Okay? And so when you go into this system, you can actually just connect your wallet and just start making these attestations. There's no transactions. It doesn't cost anything. You are just making attestations about things, and you're providing information to the community. And you can see the endorsements or disputes that have been generated by other people. You can endorse other users. And so when you get into this and you can start playing around with it, you'll see it's really fun to work with. And then this graph is linked from here. And we even have a user guide. Sorry, let me go back here. We have a user guide that explains how to use the whole system and everything that you need to know to proceed. And you can even join a Telegram channel that we have where you can talk about using the system. But also, if you're interested in this as like a research topic and you're interested in this concept of like permissionless software distribution, you can join that Telegram channel and ideate with us and contribute to the research that we're doing. Okay, so I'm going to stop with the live demo. I'm going to go back over here. And just a few more things I'm going to tell you about how to proceed with this and participate in this experiment that we're doing. So what are the rules of the game? Okay, what are the things you need to know to do this? So if you have your main account, right, this is your account that maybe has the most on-chain reputation, the one that you typically use. That's the one that you should use to go into the system, act as a trustworthy peer, and give honest reviews of snaps and other users. You can then also take another account and use that account to try to be malicious and game the system. And you can actually try to see, like, can you, break the system? Right? So we want people to test this. We want people to try, acting like a Sybil or, intentionally try to like mess up the reviews. The only thing that we ask is do not create associations with your good account and your bad account, okay? Because that's where things get weird, right? So just keep those two accounts separate. Also, we are going to be introducing dummy snaps into the system. So when you see these dummy snaps, your good account can dispute those and your bad account can endorse those. And we want to see if those dummy snaps end up being disputed by the community or accidentally endorsed, right? So we're actually trying to test how these signals over time generate community endorsements or disputes. And as you participate, you will be building your own reputation graph. So I showed you that Graph Explorer. You'll be able to access that. You'll be able to find yourself in that Graph Explorer. And you'll be able to see how your user reputation is developing. And also, if you have a snap that's allow listed, you'll be able to see how that gains reputation as well. So you'll be able to play around with that because it's updated periodically. It's actually updated as the graph changes, as the information that's coming in changes. So ready to play? You can join the Telegram group, okay? This is a QR code you can use to join the group. And you can go to this website that I just shared with you. And I just want to say special thanks to our CET and MetaMask Snaps teams who have pioneered this and put this together, as well as Karma 3 Labs who have been building this with us, especially Diane Bruni, who prepared a bunch of the diagrams that I used, and Sahil and Gloria, who helped me put together this user guide and walk me through the system. So at this time, any questions? I see a question already. Okay, do you have the microphone? Okay, great.
Hello, Boris Mann, Everywhere Computer. What unique identifiers are you using for the snaps?
So for the snaps, it's we have the ID and the version, and we're using that as a combined identifier. Sahil, is that correct? That's good? Yeah, so we're basically creating DIDs from the snap name and version. And in our system, those are enforceably unique, but it's just because we have a confined system that allows that to happen.
Content addressing, please.
Yes, yes. Yeah, so as we expand the system, we would have to do something more complex. And in the system, like in the allowless system that we have now, we use checksums on top of the versioning because obviously checksums...
Content addressing, please, not checksums. Self-verifying.
Yes. Thank you. Any other questions?
Yeah, I wanted to know, as a non-developer person who's not developer, do we have to be a developer in order to participate in the permissionless, to audit the code of a snap, and to say this is a good snap or this is a malicious snap? If not, what are the other things we should be looking at before we approve or disapprove?
Yeah, so we definitely want non-developers to participate in this experiment. And we made the endorsement or disputes based on things that like anyone could reason about, right? So it basically says like, do you think it's well designed? Does it seem secure? Or do you think it's a scam or it has some vulnerability, right? So it's not like a really concrete thing that you're claiming. It's just your sentiment, because when you have a community that's able to reason these things, then you can have a reliable sentiment from multiple people.
Thank you.
One more over here.
Okay, so what happens when you have a large amount of people saying that this looks like something that is good and is not a scam, and they're making these attestations honestly based on their knowledge or limited knowledge, and then you have a few people in the system who do have that expertise to dig deep into the snap and understand all the attack vectors, who are making negative attestations. So do those attestations get drowned out? How does this work?
Yeah, that's a really good question, and I didn't explain that. So thank you for asking that. So this is an on-chain reputation system. So certain actors in the system, if they gain a better reputation, their opinion has a bigger weight. And so ideally what you have is we have certain people in the system who have either been very reliable in their opinions that they've, their attestations that they've made, or that they have been given the trust rating by lots of other users in the system, right? So like maybe a professional auditing company that is known for being good at auditing snaps would have a very high reputation because they would be endorsed by lots of other users, or they would have made many reliable endorsements or disputes of snaps. So in an ideal system operating at scale, that weighting of that reputation would allow a small subset who are considered to be very high trust to have a higher weight than a bunch of users who maybe don't have high reputation because they don't really know, right? And so maybe they don't have consistency, or they've been found in the past to have endorsed something that turned out to be dangerous, or vice versa. So again, this is an experiment. So like we can't actually definitively say that it will always be reliable and that the outcome will be perfect, but that is why we are testing this, because we want, that's the sort of case that we want to test and see how the system responds.
Cool.
I think we have time for one or two more questions. One more question.
Seems super cool. Thanks for sharing. You think you guys can do this with NPM too, and like all other kinds of open source things? And then also, why doesn't NPM have this already, do you think?
Okay, so to the first question, yes. So if we do this right, this is my thinking. If we do this right, we have not just solved a problem for snaps, but we've solved a problem for software distribution in general. And what we're building is modular in such a way that it could be used for different types of things. And not just other like not just other like types of software, but potentially all different kinds of things that you might want to vet as a community. So as we build that system, and that's why like content addressing is so important, because you can identify anything, right? Once you have the right addressing system, and so you can actually create systems where people can vet things together. Now to your second question, why doesn't NPM have that? NPM is not built with discoverability in mind, right? It is an open system where anyone can list packages, and it's just kind of understood, like unless you're looking for a certain package, you're probably not just browsing NPM just looking for anything. But the funny thing is, sometimes I will go to NPM and just search, okay, I just need like a React Web3 modal library, and I'll search, and that's where it gets hairy, right? So this is just something that hasn't been solved. I don't know if it's just something that they don't have a way to solve it, so they just haven't been able to do it. But it's just kind of understood that like you just have to vet everything that you use from NPM. And like, sorry to go into a long story, but before my current job, I worked in medical technology. And with medical technology, we were building web apps and we used lots of packages. But obviously, people's health is in the balance, right? Like we have to make sure that the software is reliable and it's not going to crash or act weirdly. And so we had to go and vet every single package that we use. Like we had to look at like vulnerability databases, and we had to like inspect everything and make sure that like nothing had been reported. And anytime we changed the package version, we had to go through that same process again. So we had to do all of this work just because that vetting didn't exist within the system, right? So the idea here is if the vetting exists within the system, then that information is being generated by the community, and people can then rely on that.
One last question. We're good?
Okay.
Quick question. How do you prevent, first of all, first question is the logic that determines the reputation of the user, is that open source? And the follow-on question is, how do you prevent somebody reading this logic and then spinning up 1 million accounts and transacting between each other to create reputation and then voting up a malicious snap?
Yeah. So to the first part, the different modules are open source, and we're publishing that source, and also Karma 3 Labs is publishing as well. So Sahil, raise your hand. Definitely talk to Sahil after this as well if you're interested. And then the other thing I was going to say was, the intention of the system is to be able to be resilient to the sorts of attacks that you're describing, like someone just creating lots of fake accounts or trying to like upvote something. So once you have that system on chain and the different actions are on chain, then you can read the whole set of data and you can start to identify patterns of what would be malicious behavior, right? So when you can do that, then you can build a system that is able to recognize these patterns and protect from them. So the reason why we're doing this experimentation is because we want to identify these types of patterns and then make the system resilient enough to be able to prevent those types of attacks in the future. So it's all just a matter of like, as you're building the system, you're building the knowledge, the ability for the system to prevent those types of attacks. And if you have lots of actors in the system who are reliable, then that also helps prevent the likelihood that someone can try to game the system because there's lots of good actors in the system who are providing reliable signals and you're able to weight those better. Yeah, okay, thank
Cool.
you.
I think we're good. Big round of applause for Christian.